Hello students, welcome to my channel Digi Space. Today I have come with the topic of iteration statements, which is a part of a control structures. When we talk about the iterative control structures, the basic question is, what really are iterative control structures? These are basically those types which goes on repeating themselves over and over again until a certain condition is met, or until the number of iterations are met, or the final number of iterations are met. So it totally depends upon the type of the loop that is being worked on. We will discuss it in more detail in our coming slides. Types of the iterative control structures. When we talk about the different types of the iterative control structures, the first one that comes into our mind is for loops are the one in which the number of iterations are initially defined. That means it is already defined that for how many times that loop will work, or for how many number of times the variable will go on incrementing itself and the condition will be executed or the statement is executed. It follows the following sequence. Step 1, initializing the starting value of the variable count. Step 2, set the condition to repeat the loop as long as the condition is true. That means set the number of times that variable count would be incremented or would reach to its final value. And step 3 is increment the value of the variable after executing the statement. While loops. These are the one in which the number of iterations depend upon the condition statement. That means we cannot say for sure that for how many times that loop would be executed, but it totally depends upon as soon as the condition is met, that or as long as the condition is true, it will be executed. No matter if it's true for 10 times or it is true for one time only. So the condition is evaluated every time and the statement executed only when the condition is true. While as long as the condition is false, the structure is skipped and you move on to the next step, or you exit the program. Are the repeat until loops. In these loops also the number of iterations depend upon the condition statement. But here there is a slight difference from the while loop. Here the statement would be executed as long as the condition stated in the repeat until loop is false. And as soon as it becomes true, that means it will exit that loop. One more thing is in the repeat until loop, while in the while loop, the condition is first checked, tested, and then only execution is done. But in the repeat until loop, for the first time, it will be executed without checking the condition, and after that, the condition would be checked for the next steps. So normally the repeat until loops are used in places where we do verifications. We will discuss it in detail in our upcoming presentations. Clearer concept about loops, especially for loops. Consider the pouring of the ice cream from the main bowl into 7 different cups. Since you are doing the same process of scooping out the ice cream 7 times over and over again, that means you are under the effect of a for loop that starts from the first time you scooped out the ice cream and will go on running until the 7th cup is filled. A second example is from the nature. When the sun rises every day in the morning in most of the countries, except for a few countries obviously where there are 6 months of the daylight and 6 months of the night time, the sun is actually under the effect of the loop that it rises up in the morning and sets in the evening. Now that we have discussed the examples of the for loop from the nature and from our life as well, we move on to discussing the syntax of the for statement. It begins with the keyword for followed by the round brackets in which the first part is the initialization of the variable. separated by a semicolon, and then the condition, that is, if this defines the final value of the variable, separated by a semicolon once again, and then the incrementing of the variable. After that, it is followed by the opening and the closing brackets, which defines the statements in it. So the for loop, as long as the for loop is true, the statements that are between the opening and the closing curly brackets would be executed. Talking about the pseudocode of the for statement, it starts off with the keyword for followed by the count, which defines the initial and the final value of the count. The statement 1 would be executed next and the count would be incremented. But as soon as the count would reach its final value, it will look for the end for keyword and will come out of the for loop. Whereas in the flowchart, it starts off with a rectangle in which the initialization of the for loop is done, or the initialization of the variable is done, followed by the checking of the condition. When the condition is true, it will execute the statement 1, and after executing the statement 1, it will increment the value of the variable. After incrementing the value of the variable, it will again go back to the condition and will see whether that variable is falling within the range that is specified in the condition. And so as long as the condition is met, that is, it is satisfying the range of the condition, the statement 1 would be executed. But as soon as it dissatisfies that condition, it will move on to the no statement, to the no structure or the no part of the decision structure, and will move either towards the exit or towards the next task that is given to it. Let's consider a program to print the squares of the numbers from 1 to 20. Starting off with the algorithm, step 1 is start, step 2 is for count, which will run from when the value of the variable count is from 1, and it will run till the value is 20. So this is actually defining the range of the for count. As long as this range is true, or the value of count remains within range, it will write down the square of the value of the count, that is count into count, and it will increment the variable. So for count 1, it will write the value of the square and increment it to 2. It will again go to the for loop, check the value of the count, whether it is between 1 to 20. Yes, it is. And it will again write down the square of the number. So this will go on and on until the value 20 is reached. As soon as the value 20 is reached, it will look for the end for, and as soon as it finds end for, it will exit the loop, and hence will move on to the next step, which is step 3, exit. Talking about the flowchart, it starts off with the start in the oval, then the initialization of the variable count, which is done in a rectangle since you are setting the value of the count equals to 1. After that, the decision is to be made. It will run as long as the value is less than equal to 20. If it is a no, that means the value is not true, or the value of the count is greater than 20, then obviously it will move towards the exit. But as long as the value is within the range 1 to 20, it will go on writing its square, and it will increment the value of the count. After incrementing, it will again check whether the value of the variable is within the range. In this way, it will go on writing down the squares, go on incrementing the variable until the value 21 is reached, this time after incrementing. On 21, it will check again. This time the decision is a false, and it will exit the program. Coding it in C, let's start off with the keyword for, which is followed by the initialization, that is integer type of the count, initialized to 1, followed by a semicolon, and then the count variable is the condition is given that till what value of the count this would be executed, this for loop would be executed again, separated by a semicolon, and then the incrementation of the variable by count plus plus. Please note that this is not terminated by a semicolon. Well, in fact, we move on to the next line, and then we insert the opening and the closing brackets. Within this, we are in this program, we don't need to go into too much detail, so we directly write out the printf statement. The square of the number %d is %d. In place of %d, in first one, we are going to put the value of count, so we separate it by count. And in the second %d, we are going to place the number count into count, that is the square of the number.
count. Please note here that in printf I have placed \n because every time it is going to calculate the count and print it, it will move on to the next line and print the count of the next number. Let's execute it, and on executing we find that it is giving the output of the squares of the numbers from 1 to 20. I hope you understood the topic of the for loop. Don't forget to like, subscribe and share this video. Meet you soon in our next video. Thank you. Coding it in C, let's start off with the keyword for, which is followed by the initialization, that is integer